Welcome back. As always, make sure to subscribe to my channel for more chemistry videos. And also make sure to check out the past two videos on Lewis structures. So the purpose of this video is to go through the general shapes and polarity of some simple molecules. Okay, so when we look at molecular geometries, all we're talking about are the three-dimensional shapes of the molecules that we have been drawing Lewis structures for. And for the purposes of this class, you only need to learn 5 of them. And you'll be given this list of linear, trigonal, planar, bent, tetrahedral, and trigonal pyramidal, but you will not be given the number of atoms or lone pairs attached to each. So it may be good to go and create some flashcards based on your molecular geometries. Okay, so there are 5 that we're going to learn. The first one is linear. Okay, and we can see it here on the right. You have a central atom with 2 atoms on either side, and so you have a total of 2 atoms attached to your central atom and 0 lone pairs. And if you have 2 atoms and 0 lone pairs on that central atom, it's linear. The next one is trigonal planar. And again, we're going to have 0 lone pairs, but this time we have 3 atoms. And that will give you a trigonal planar structure. If we replace one of those 3 atoms with a lone pair, so that we have 2 atoms and 1 lone pair, we now have what is called a bent structure. And if you ever have 2 atoms with any lone pairs, whether it's 2 or 1, both of those structures are going to be bent. So as you see, we have 2 bent structures here. But both have 2 atoms and some number of lone pairs attached to that central atom. Now the fourth one is tetrahedral, and tetrahedral is going to contain 4 atoms and 0 lone pairs. The last one, we're going to replace one of those 4 atoms with a lone pair, so that we have 3 atoms and 1 lone pair. And 3 atoms and 1 lone pair leaves us with a trigonal pyramidal structure. So make sure that you take note of the differences between trigonal planar and trigonal pyramidal. Okay, and whether you say trigonal pyramid or trigonal pyramidal, I will accept either. But again, you're going to have a list of these names. You just will not have the list of atoms and lone pairs attached to them. But a trigonal planar does not have any lone pairs. It has 3 atoms and 0 lone pairs. A trigonal pyramidal will have 3 atoms and 1 lone pair. So the difference there is that planar has 0 and trigonal pyramidal has 1. Okay, the other topic for this video is polarity, where we're looking at polar versus non-polar compounds. And when we're talking about polarity, what we're talking about is the distribution of charge. So if you have an uneven distribution of charge, then you are called polar. If you have an even distribution of charge, then you're non-polar. Okay, so uneven distribution is polar, and even is nonpolar. So if you have an uneven distribution of charge, you're going to be what we call asymmetrical. And the way that you get asymmetrical is one of 2 ways. Either you have a lone pair of electrons on the central atom, and that's important that your lone pairs are specifically on the central atom. Any other lone pairs do not count. Okay, and another possibility is that you have different atoms around a central atom. So in our example here of a polar molecule, notice how the oxygen has 2 lone pairs of electrons, and the oxygen is your central atom. So those lone pairs are what make it polar. And then nonpolar is only going to happen if all the atoms around your central atom are the same and you have no lone pairs on that central atom. So you have to meet both of those qualifications. And if we look at the second example here, notice how you do not have any lone pairs on the central atom. You have lone pairs on the oxygen, but those don't count. Okay, we're looking specifically at this carbon in the middle. And the fact that there are no lone pairs on that carbon and that both atoms attached to the carbon on either side are an oxygen atom, that means that you have a non-polar molecule. Okay, so if you're not polar, you're non-polar. Okay, so again, to be polar, you're either going to have lone pairs on the central atom or a different atom attached to that central atom. And if you're nonpolar, you have all the atoms the same around the central atom and no lone pairs on that central atom. Okay, so we are going to run through several examples here using the Lewis structures that we created in the past videos. And each time we're going to determine what's the molecular geometry and is that structure polar or nonpolar. So the first example is CH4. And if you remember, carbon was singly bonded to all four of those hydrogens. Okay, so when we're determining the molecular geometry, the first thing that we want to know is how many atoms are attached to the central atom. And so circling around that central atom, we have a total of 4 atoms attached to carbon. And there are no lone pairs on that carbon, so we have 0 lone pairs. And if you go back to the table that we saw at the beginning, if you have 4 atoms and 0 lone pairs, that structure is tetrahedral. So CH4, 4 atoms, 0 lone pairs is tetrahedral in structure. Okay, so that answers part A. And then part B, we were asked, is it polar or nonpolar? And remember, if you want to be nonpolar, all of the atoms around that central atom have to be the same and no lone pairs on the central atom. Well, all 4 atoms around the carbon are hydrogen. So you have all hydrogens around carbon and no lone pairs on the carbon. So therefore, this molecule is nonpolar. Okay? The next example is NF3. And if you remember, nitrogen has 3 bonds, each one to a fluorine, and 1 lone pair on the nitrogen. And all the fluorines had 3 lone pairs. But the lone pairs on the fluorines don't actually matter when we're determining molecular structure and polarity. Okay? So to determine the molecular geometry, the first thing we want to look at is how many atoms are around that central atom. And we have 3 atoms. And then in terms of lone pairs, we have 1 lone pair on the nitrogen. And remember, it's only the lone pair on the central atom that matters. And then looking back at that table, if we have 3 atoms and 1 lone pair, that is our last structure, trigonal pyramidal. 3 atoms and 1 lone pair. Trigonal pyramidal. And then to determine if it's polar or nonpolar, remember that to be nonpolar, you cannot have any lone pairs on the central atom. So as soon as I see a lone pair on that nitrogen, that automatically indicates that it's going to be polar for the purposes of this class. Okay, so a lone pair on that nitrogen should tell you that it's polar. Okay, the next example we had SF2, and remember sulfur has 2 bonds and 2 lone pairs. And since the lone pairs on the outer atoms do not matter, I'm not going to fill in those 3 lone pairs around fluorine. They're there, but they don't matter for this question. What does matter is how many atoms are attached to that sulfur. And we have 2. So 2 atoms attached to the sulfur, and we have 2 lone pairs on sulfur. Okay, so if we have 2 atoms and 2 lone pairs, find 2 atoms and 2 lone pairs, and that is your bent structure. Remember, if you have 2 atoms with any amount of lone pairs, that's going to be bent. So for SF2, we have a bent structure. And then for part B, remember, if you have a lone pair on that central atom, it's automatically polar. Okay, so we have 2 lone pairs on sulfur, and therefore that structure is polar. Okay, in our next example, CO2, remember this was one of those multiple bonded structures. So the carbon was double bonded to an oxygen on either side. And there were lone pairs on those oxygens, but we don't care for the molecular geometry. The fact is there's no lone pairs on the carbon. So that carbon has 2 atoms, one on either side, and no lone pairs. So if we have 2 atoms and 0 lone pairs, just by looking at the picture, the molecular structure or the molecular geometry is linear. Okay, now keep in mind it's not going to be linear if there are lone pairs on that central atom, but if there aren't, 2 atoms, 0 lone pairs is a linear structure. And then for part B, for whether it's polar or nonpolar, remember there are 2 rules for being nonpolar. First, you cannot have any lone pairs on the central atom, and we don't. So there's no lone pairs on carbon. And the second thing is that the atoms around carbon have to be the same. So are our outer atoms the same? And they are because they're both oxygen. Okay, so we have no lone pairs on carbon, the outer atoms are the same, and therefore this one is nonpolar. So in our last example, we have CH2O. And here, carbon is the central atom. It's singly attached to each hydrogen. And then to fulfill 4 bonds to carbon, we have it doubly bonded to oxygen. And that also makes oxygen happy with 2 bonds on oxygen. And oxygen will have 2 lone pairs, but those do not matter for the molecular geometry. So the question is, how many atoms are around the carbon? And there's 3. So we have 3 atoms on carbon with 0 lone pairs. And so the structure for that is trigonal planar. And then it's going to be polar because the oxygen is different than those hydrogens. Okay, so again, remember, if you have a different atom, that's going to indicate a polar molecule if a different atom is attached to the central.